whilst I'm going around having a look at your homework, you guys have a look at this Valentines puzzle. Okay, see if you can figure it out. I will give you 5 minutes to get me a solution. Pair up the boys and the girls. Alright, so we did a puzzle like this not that long ago. The easiest way to set this up is with a table. Come on, we've had too long. I'm going to put the names of the guys along the top. So we've got X for Xavier. We've got Jaden for JA for Jaden. JE for Jesse. And Devon. Alright, we've got the girls, which are Marissa. We've also got Autumn. We've got Aaliyah, A-A-L. And we've got Melanie. Okay, so if we set it up in a table like this, we can fill in this table nice and easily just with crosses and ticks, depending on who sent who, or who may have sent who. So the first bit of information in this, Ian, is what? Just in the puzzle, what's the first thing they tell you?
Oh, sorry, Xavier did not send the card. Oh, like the.
Yep, that's right.
Oh, Xavier did not send the card to Marissa.
Right, so Xavier didn't send one to Marissa. So what could I put here? Okay, that did not happen. Jaden sent a card to either, so here's Jaden, Autumn, or Melanie. So Jaden sent one to either of those two. Don't know which one. Autumn did not receive a card. Here's Autumn from Jesse or Devon. Neither Jesse or Devon sent a card to Aaliyah. So these two guys didn't send one to Aaliyah.
Or Aaliyah.
Yep. Devon would never send a card to Marissa. A bit harsh. Devon would never send one to Marissa. So who did Devon send one to?
Not Marissa.
Not this one, not this one, not this one, but
Melissa.
Melissa or Melanie even.
Sorry, Melanie.
Why did he not send one to Marissa?
Because I think it says.
No, never mind.
Okay.
Devon would never send it to Marissa.
What, the love find? It's
All right.
love find.
It's way.
Let's go back to this information again. Jaden sent a card to either Autumn or Melanie. So we know that, did they send one to Aaliyah?
No.
What about Marissa?
No.
So who did Aaliyah definitely get a card from?
Xavier.
Yep, Xavier. Okay, that's the only option.
What? Wait, Aaliyah? I said that. I got it right.
You got the first bit right, yeah?
No, you told me that I got that one wrong.
I said the second one.
No, that was Xavier plus Aaliyah. Got it?
All right. So looking then, what else can we fill in here? Who's Marissa getting a card from? Yep, Jesse. We have said that Devon is definitely sending Melissa a card.
Autumn. Jaden.
Hold up. Devon would never send a card to Marissa. Oh yeah, there's Marissa there. Yep. So Devon has definitely sent. Who did Devon definitely sent a card to? All right, good job, Eliza. Okay, we've got a tick here for Devon, a tick for Jesse, a tick for Xavier. We need to put the last tick in. Jaden must have sent a card to Autumn. And not this one, not this one. All right, so we've got Xavier and Aaliyah, Jaden and Autumn, Jesse and Marissa, Devon and Melanie. I must have done it wrong earlier. Okay, so sending out in a nice little table definitely helps. Okay, looking at the homework that I've gone around and seen. We all filled in our table. Nicely, just give me the values here for cost. Cost of 0?
0.
Cost of 0 is? Cost of 30?
0.87.
0. Cost of 60?
0.5.
Cost of 90?
Zero.
0. Cos of 120?
Negative,
0.5.
0.8.
Negative 0.5.
0.5, yeah, 0.5.
Okay. Cos of 150?
Negative
Negative
0.8.
8.7. 87. Negative. Negative 0.87.
Cos of 180?
Negative 0.87. Oh, wait, what? Negative
Okay,
1.
and so on, okay? And when you come to draw this, if I scroll down here, okay, so that's our sine graph. What's the difference? Well, like, how does it look comparatively toward, like, compared to the sine graph?
It's same like wave sort of.
It's a wave shape, yeah, but what
But
else?
it's like, it's different.
If you had to compare them,
It starts at 1.
it starts at 1, right? It goes down. Does it look the same, though?
No, not exactly the same.
But just
Yeah,
Very
it's
similar.
the same kind of like.
It's the same shape. Don't stop
The
laughing at
first
my
one-
diagram.
The first one, it starts at 0 and goes up. The second one starts at 1.
Stop laughing at my diagram. Okay. It's the same shape, okay? If I go into... Oops, I didn't want to undo that.
Good.
It's not that bad.
If I go into Desmos... Alright, so there is our y equals sin x. If I put in y equals cos x... Well, how can you, like... Give me a couple of words to describe the shape of, you know, cos compared to sin.
The blue one's slower than the green.
Not necessarily slower. Yep. Damon? It goes deeper? Well, it kind
No,
of
never mind.
goes to the same point, but it's just been...
Big sign's wide.
Extended. Lengthened.
Let's look at, say, from this point to this point. What do you notice about this point to this point compared with this point to this point?
The same.
It's the same, okay? So the cos one has just been shifted backwards, okay? The whole of the sine graph is the same as cos except shifted, okay? Yesterday when we looked at this, if I put this in degrees, so we went from 0, let's do it up to 540, okay? So we have our degrees. Okay, so there's up to 360 in around here. Okay, so cos and sine. Right, so a couple of things that we need to talk about with this. Let's go back to here. Before we get to that, here we go. What do you notice when the graphs get to 360?
They. Ooh, I know this.
starts over.
It starts over again, good.
They start over again.
And that's
Because
very important.
It's always around the circle. I don't know. It's full way around.
Okay, it repeats.
I don't know what I'm talking about.
And can you describe the relationship between the graphs of sine and cos?
Cos is just behind.
Behind, so cos is a, if we say not behind, what was the word that I used? Yes, shift,
Adjacent.
a shift, okay? And we'll say it is a shift in what direction? Well,
Right.
to the
Left.
left or right?
Left.
To the left. Okay. Can we actually say how many degrees it is shifted? If we go back to the graph on Desmos.
2.
3.
Ooh, I know.
How many degrees is it to this
3.
point?
It shifted 3.
Listening, how many degrees to this point?
Oh,
Here's
90.
90, okay. And this is the top of the sine graph. This is the top of the cos graph. So how many degrees has it gone from
0.
here back to here?
0.
From here back to here? 90 degrees.
Oh, right,
Okay,
right.
because that's 90 degrees along.
Yep, yep.
Okay. Keeps bringing up the wrong one. Shift to the left, 90 degrees. I recommend that you get this stuff down. All right, we're going to write this down, okay? The amplitude
Where did we write that?
in your book, yeah. Of a trigonometric graph
Oh, is that not the title?
No, so this is just a sentence, okay? Well, a sentences. Is equal to half the distance of the maximum point to the minimum point. Trigon. So if we write down the amplitude of y equals sin x is and we're going to mark this in our diagrams as well, okay? To make it obvious. No. Yes. Okay, if I jump back to the diagrams. Okay, so if I go back to here to our sine graph, I'll put the sentence up the back in a second. We said the amplitude is the distance from the maximum point to the minimum point, half of it, okay? So what is the maximum point on this curve?
90 degrees.
No, the maximum. So we're looking at the... No, there's 180, but the max, if you're looking at this curve, you're thinking if you're cycling along it, okay? What's the maximum point? 1. Okay. Okay, so we're looking at the maximum point on the y-axis, okay? Not on the x-axis. So if you think, the way that I like to think of it is if you are cycling along this, you're having to cycle up the hill, you get to the top of the hill, which is the maximum. Okay. What is the minimum point on this graph?
-1.
-1, right. So what is the distance? Okay, now we're talking about the distance between here and here.
2.
Okay, good. Okay, that's the absolute distance. So what is the amplitude? We said the amplitude is half of it, which is 1. Okay, so the amplitude is 1. So from here up to here is the amplitude. So draw that in, please, on your diagram. I'll draw it a bit neater. A nice straight line. Let's do red. So from there to there is our amplitude. Still can't draw.
And the amplitude is 1.
Amplitude is 1.
So what was the total when I was from the bottom to the top? Is that the total?
So that's just the distance from the maximum to the minimum.
So does that mean it'll be 1 for code?
Exactly, good. Okay, if we look at cos as well. The maximum value for cos is
1.
1. The minimum value for cos is -1, so the distance between them is
2,
2. So the amplitude is
1.
1. Bring it today. I'm just going to freehand draw it. So from the top down to the bottom. Okay, and then write it in where we've been taking our note.
Are we going to do the amplitude of x?
No, it's the amplitude of the graph, okay, of this whole graph. Now, last bit of terminology for today. I'm going to write this down as well. We've already kind of discussed this. The period is the horizontal length of one complete cycle. The graphs of y equals sine x and y equals cos x and period of and we can have a think about that.
So 540.
So if we go to our graph, I'll put the words back up in a second. It said the period is the horizontal length. So the horizontal length is looking at this axis or x-axis of one complete cycle. So when does it start repeating? 360, you're right. That's one complete cycle, okay? From 0 to 360. Is it the same for cos? When does it start repeating?
360.
Yep, 360 as well.
Is that for like any number?
No.
It's like a full.
It'll work for sine x, cos x, okay? If we start putting other numbers in, it will change it, okay? Does everybody see you, okay? It's just when it starts to repeat. Yes? No? Eliza? So they both have a period of being extra messy today. 360 degrees. Right, so sine x, cos x both have an amplitude of 1. They both have a period of 360 degrees. What is the amplitude again? How do you work out the amplitude?
The distance from the top of the
Okay, the highest point, the maximum, to the lowest point, to the minimum, and you have to
not by 2.
yeah divide it by 2. Okay, so it's the half the distance. Okay, between the max and the min. All good. Right, we've got about 8 minutes. Okay, what we need to start then consider is what happens if we start to put numbers in front of the sine x. How is that going to affect the shape of our graph? How is it going to affect the shape of the amplitude? How is it going to affect the period? Okay, so you guys are going to do this for me. What do you think, Eliza?
I was gonna say it's gonna like multiply by 2, so it's gonna get much larger.
It's going to get much larger. How?
Because our graph isn't gonna be 1, 0, -1. It's gonna be 2, 1.
Right, okay, that seems to make sense, okay. We're going to do it we're going to draw first off the graph of y equals 2 sine theta. So let's copy it down this, okay? I think I might have a sheet, I'll go and have a look. But we can copy down, we're going to draw the graph of y equals 2 sine theta, okay? So this is what we're going to do now, okay? And then to do it, we've already got our values for sine theta. We are now interested in 2 sine theta. So what's going to happen to all of, what are we going to do to all these values? Yep, Eliza? Yeah, we're going to double them, okay, to get these values. And then we're going to plot them and see what we get, okay? So